Hello students, this is Mr. Yao. Today we are going to continue to learn more about different forms of quadratic functions. First, let's review what we have learned in the last lesson, which was finding the zeros of functions. In this case, I didn't specify it's going to be quadratic functions, that's why they could get a bit more complicated. So let's have a look at the first one, of x equals x cubed minus 2x squared minus 4x. Well, the first thing you should notice is at least you should be able to factor out an x. So let's set it equal to 0. That's how we actually find a 0 by solving equations. We can factor out an x, and we're left with x squared minus 2x minus 4 equals 0. Okay, so first, this for sure is going to give us x equals 0. And then we need to deal with inside the parentheses. You have two different ways. You can either choose to complete the square, or you can actually choose to use quadratic formula. This one, completing the square, is quite easy. So minus 2x, then a space, which is going to equal to 4, and a space. So negative 2 over 2 is a negative 1. That means inside the space, we're going to need a plus 1 and a 1 on the right side. And again, this 4 comes from moving the negative 4 to the right side. So basically, I've set this equal to 0 and solved that. Okay, so we're going to have x minus 1 squared, that equals to 5. Taking the square root, x minus 1 equals plus minus square root of 5. So our final answer, x equals 0. And then move the 1 over, is a 1 plus square root of 5, and a 1 minus square root of 5. These are the zeros for question A. Question B. Same thing, let's set it equal to 0. But we can actually factor out a 2, so we can divide everything by 2. We're going to get a 3x squared plus x minus 2 equals 0. This one you can actually factor. If you want to use the diamond, cross, big X, whatever you want to call it, negative 6 and a 1, 3x on the top, and we're going to need a combination multiplied to get a negative 6 and adds up to a 1. It's going to be a negative 2 and a 3. That one can be simplified to x over 1. So 3x minus 2 times x plus 1 equals 0. Our zeros would be, that one give us a 2/3, and that one give us a negative 1. There you go. That's question B. Moving on. We're going to continue talking about the first one, which was from standard form to vertex form. So let's quickly review the vertex form. That is f of x equals a times x minus h squared plus k. The reason this is called the vertex form is because we can easily identify the vertex, the number inside the parentheses, but of course, it needs to be subtracted, so it's the h, and then the number outside the parentheses is our k, so h comma k is our vertex. Vertex is the point where the graph changes direction. The vertex is either the highest point or the lowest point on a quadratic graph. Even though we haven't learned more about the graph, but at least you should know the graph for a quadratic function is called a parabola, and looks like that, or this. So it's either the highest point or the lowest point, that is the vertex. Since vertex is the most identifiable point, we often convert the other two forms into vertex form. We have talked about converting standard form to vertex form using completing the square, and it gives us this result, which in other words, h is going to be negative b over 2a, and my k is going to be this negative b squared minus 4ac on the top, which basically is 4ac minus b squared, the whole thing over 4a. Now, this seems to be a quite long process. If every single time we try to convert from standard form to vertex form, we're going to have completed a square. So maybe we can just use the result of completing the square. So there is a shortcut, because as long as we can identify the h and the k, we will be able to write the vertex form, since the number in front is just the leading coefficient. So there is a shortcut. The shortcut is to just use the result of h, which is negative b over 2a. We're not going to even use the result for k, because as soon as we have h, we can do something else to find the k. So here's the shortcut. We're going to find negative b over 2a, and that is our h. So again, that basically means h is negative b over 2a. And as soon as we have that, because hk is actually 1 point on the graph, that means if we found h, we plug it in, we will be able to find our k. And then we keep the leading coefficient, and we will have our vertex form. So let's practice. instead of saying find the zeros, we're actually finding the vertex form. We're actually converting it to the vertex form. Negative b over 2a, well, they are already all in standard form, so we can directly start identifying that. Our a in this case is a 1, our b is a 12, so it's negative 12 over 2a is a 2 times 1. So it's going to be a negative 6. And as soon as we have h, that means we can just plug it back in to find the k, because hk is a point in this function or on the function graph. So f of negative 6 is going to give us the k. Let's plug it in. Negative 6, when you square a number, make sure you put it inside parentheses, plus 12 times negative 6, and plus 7. We got a 36 minus 72 plus 7. So it's a negative 36 plus 7 is a negative 29. That means our h is a negative 6, our k is a negative 29. So we can easily write into the vertex form. Don't forget, in the front, we are still going to have this 1 as our leading coefficient. So 1, but we don't have to write the 1. So we're going to start with x, but our h is going to be the opposite number since it's always x minus h. Whatever we found h to be, we need to use the opposite to put inside the parentheses. So it's actually going to be a plus 6, and then squared, it's negative 29, is going to be on the end. The k doesn't need to be flipped because it's just a plus k, whatever k is. There you go. That's example 1. You can pause here and try example 2 and 3. Hopefully you have finished trying. Now let's have a look. Same process. H is negative b over 2a. Our b is an 18. Our a is a 3, so it's 2 times 3. We got a negative 18 over 6, which is a negative 3. Then we're plugging it in to give us the k. So its k is going to be f of negative 3. That is 3 times negative 3 squared. Remember, when you square a number, always put it inside parentheses. Plus 18 times negative 3, and minus 2. That will give us a 3 times 9, which is a 27. 18 times negative 3 is a minus 54. The minus 2 on the end. So we got a negative 27 minus 2. Oh, it's another negative 29. Now let's write the vertex form. F of x equals, don't forget the leading coefficient, which was the 3. And then x, this h always has to be the opposite, so it's a plus 3 squared. And then the k on the end, which is a minus 29. There you go. That's example 2. Example 3, same thing. H equals negative b. My b is a negative 8. 2a, 2 times my a is a negative 4, so it's 2 times negative 4. Oh, there's a lot of negatives. So negative sign in the front. On the top is a negative 8. On the bottom is also a negative 8. So we have 3 negative signs combining together, which leaves us a 1 negative sign. The 8 and 8 simplifies to be a 1, so it's a negative 1. For our k, is going to be f of negative 1. Let's plug it in. Negative 4 in the front, then it's negative 1 inside parentheses being squared, minus 8 times negative 1 plus 3. Negative 1 squared is a positive 1 times negative 4 is a negative 4. Negative 4, then we have this negative 8 times negative 1, which is going to be a plus 8. So we got a negative 4 plus 8, which is going to be a positive 4, plus 3, which is a 7. Let me actually write it out. We actually got a negative 4 plus 8 plus 7, plus 3. That's a 7. Okay, let's write the final answer. F of x equals, don't forget the leading coefficient, which is a negative 4. And then h is always the opposite. So it's going to be plus 1 squared. K is just exactly what it is. So plus 7 on the end. That is example 3. And that's how we actually convert from a standard form to vertex form. We have the shortcut. We just identify the negative b over 2a and then plug it in to find what we need for k. One thing to always be careful is the h is going to be the opposite of what we got. Okay, moving on. Standard form to intercept form. If a quadratic function is given in standard form, we factor it to rewrite the function in intercept form. But like I have talked about in the previous lesson, we do actually have a bit of an extra step that we have to go through. So no matter what, we are going to try to factor first. So there you go, example 4. Let's set it equal to 0 and factor. For sure, we can divide everything by a negative 2 because that is going to be the GCF. So that can make our factoring a bit easier. We are left with a 12x squared minus 7x minus 12 equals 0. There you go. We can use our cross diamond, big X, whatever you want to call it. On the top is a negative 144. On the bottom is a negative 7. We need two numbers to multiply, get a negative 144 adds up to a negative 7. It's going to be negative 16 and 9. On the top is going to be 12x. Both could be simplified. That simplifies to be a 4x over 9. This simplifies to be a 3x over negative 4. And we're going to get a 3x minus 4 and 4x plus 9. Now here's the issue. In order to use the intercept form, we actually need to find the x-intercepts. Or in other words, we need to find the zeros. So we're actually going to need to solve them. This one is going to give us a 0 of 4/3. This one is going to give us a 0 of negative 9/4. And these are the numbers we are going to put inside the parentheses. Here's another way you can think about it. Because our goal is to get x to be inside the parentheses. No number in front of the x. So in other words, we can also choose to just use the 3x minus 4, divide everything by 3. That's going to leave us x minus 4/3. And then for the 4x plus 9, we're going to divide everything by 4 since we just want to leave an x. So now we're going to get x plus 9 over 4. I do recommend using this method. The reason if you choose to use the other method to find the zeros, you may notice you have to always remember to use the opposite number to put inside parentheses. Now lastly, let's not forget we are going to need the leading coefficient. Our leading coefficient is not 12, it's actually whatever was given. It was negative 24. The reason we got a 12 is because we divide everything by a negative 2. So the leading coefficient was actually a negative 24. And that is our intercept form. That is example 4. Moving on, example 5. Say same thing, set it equal to 0. We can get rid of the GCF. So you got x squared minus 8x plus 16 equals 0. Well, you can either use the big X or you can quickly rewrite them. Because just an x squared in the front, so each parenthesis is just going to get an x. We need two numbers to multiply, get 16, and adds up to a negative 8. It's going to be a minus 4 and another minus 4. So in this case, you can see we already have just x in each parentheses. So we can quickly write into intercept form. X minus 4 and another x minus 4. But we have a negative 3 in the front. Some of you might be like, well, can I actually write it as a square? Well, here's the issue. If you write a square, then suddenly we can't tell if it's a vertex form or intercept form. Because if you write as a square, negative 3, then x minus 4 squared. Remember, that is a times x minus h squared plus k. Just our k in this case is a 0. So we don't know if that's intercept form or vertex form. So preferably, we're still going to write them separately. That is example 5. Now a bit more practice. Example 6 and example 7. Okay, 6 equal to 0. But we can actually factor because, we can actually get rid of a GCF. Negative 196 and 64. They could at least both be divided by, let me think, a 4. Or a negative 4. So divide everything by negative 4. We are going to get 49x squared minus 16 equals 0. Well, we can totally factor that. Because 49 is a perfect square, 16 is a perfect square. That is the difference of squares. We got 7x plus 4 and 7x minus 4 equals 0. Remember, my recommendation is let's think directly to get the 7x down to just an x, which means for this, we're going to divide everything by a 7. We got an x plus 4 over 7. This one, same thing, divide everything by a 7. We got x minus 4 over 7. In this case, you do not have to worry about finding the zeros. Then make sure you use the opposite number inside the parentheses. Okay, so finally, our intercept form, we're going to still use the leading coefficient. Remember, it's not 49, it's negative 196. And we have x plus 4 over 7 and x minus 4 over 7. That is example 6. Last one, example 7. Same thing, set equal to 0. There's a GCF we can divide. So let's divide everything by a -4. We got 6x squared minus x minus 15. That equals to 0. You can use the big X or cross or diamond, whatever you want to call it. -90 on the top and -1 on the bottom. The combination should be fairly obvious. It's a -10 and a 9. On the top, 6x. The right side simplifies to be a 2x over 3. The left side simplifies to be a 3x over -5. So we're getting a 3x minus 5 and a 2x plus 3. Okay. Now, in order to actually keep the x inside the parentheses, we're going to need to divide the first one by 3, which gives us an x minus 5/3. Second one needs to be divided by 2, since the number in front of x is a 2. That's going to give us x plus 3/2. Final answer, f of x equals, don't forget, we're using the leading coefficient in the original function, not after we have divided everything by -4. There was a -24 times x minus 5/3 and x plus 3/2. That is example 7, and that is everything for this 4.9b lesson. Thank you.